Hey guys, welcome back. So this video is going to be part 2, solving the equations with the double angle formulas. And so we've talked about the double angle formulas, so now we're going to basically use those in order to solve equations. Remember, solving equations can get a little tricky. But basically, now that we have a good sense of how to solve the equation, right now your goal is going to be able to set up those equations with just one of the trig functions. So we're going to start with one example right here. Basically, I want you to find the exact solutions on the interval of 0 to 2 pi. Notice we're going to want every possible value that exists. Now, what we're going to first start with is when you see that you have the sine of 2x and the sine of x, realize that the sine of 2x is non-comparable to the sine of x. You can't just pull out a sine of x in that case or factor it out. So what we're going to first do is you're going to replace the sine of 2x with your trig function, which was 2 sine of x times the cosine of x. Now, once you have all of the angles in the equation the same, that's when you can go, wait, what can I factor out of this? In this case, I can factor out a sine of x in both the left and the right term. So I'm going to pull a sine of x out. That's going to leave me with 2 cosine of x minus 1, and that's equal to 0. And now we'll do this stupid t-chart, where we basically say the sine of x is equal to 0, and 2 cosine of x minus 1 equals 0. So in this case, we're looking for when does the sine of x equal 0, and when 2 cosine of x minus 1 equals 0. So let's solve, the left one's already solved. We have the trig function with x by itself. So I'm going to add 1 to both sides here. I end up with 2 cosine of x equals 1. Divide by 2. The cosine of x will be equal to 1/2. And then we're done. Now, what we need to remember is that we are looking for all the values between 0 and 2 pi. So the question we're asking is, when does the sine of x equal 0? Now remember, when it's 0 or 1 or -1, that means it's a quadrant angle. We're looking for the radians that make this angle work. So in this case, we know that the sine of 0 radians as well as pi radians will make the sine of those values equal to 0. Now the second question is asking us about the cosine. Now the cosine of x is equal to 1/2. Now the important thing to remember is that all students take calculus, and we have a positive cosine value. So we know that our answer is going to be in quadrant 1 and quadrant 4. Now, this is when you need to remember your reference angle, everything like that. So the cosine of, I believe it is pi over 3. So pi over 3 would be your reference angle. Angle is pi over 3. So therefore, x is going to be equal to pi over 3. And that would give us our answer in quadrant 1. In quadrant 4, the answer with pi over 3 in it, the angle that has a reference angle of pi over 3 in quadrant 4 would be 5 pi over 3. So our answers in this case are 0, pi, pi over 3, and 5 pi over 3. Now that was a pretty simple example because there's nothing really crazy algebraically. But if we take a look at our next one, it's going to get a little bit trickier. The cosine of 2x minus the cosine of x equals 0. Now, one thing to mention is that you want to have something in common between each term. So what we're going to do in this case is I'm going to replace the cosine of 2x with something that we know would be the easiest would be to use that formula 2 cosine squared of x minus 1 minus the cosine of x equals 0. And the reason I wanted to use the cosine squared of x just by itself instead of the cosine squared of x and the sine squared of x is because when I'm looking at this problem, I'm going, wait a minute, if I have the cosine in the right term, I'm going to want just cosine involved with the problem. You could theoretically do it with sine, or complete the problem with sine, but it gets a little trickier. And at the end of the day, you end up with something like this anyway. So what we're going to do here is let me rearrange this so that you have 2 cosine squared of x, and we're going to go in the order of degrees for the cosine. So therefore you have the squared, the single, and then the no cosine. Now, what's tricky about this question is that it's scary looking because you have that cosine squared. So on the side here, I'm just going to show you guys something. If I said this was 2c squared minus c minus 1 was equal to 0, my question is, how could you solve for c? Now in this case, c represents the cosine of x. Now, you should realize that this is just a factoring question, so we could do the guess check method or the grouping. But in this case, I'm looking for what two numbers will multiply to negative 2, because you have to do that rainbow thing. That will combine to be negative 1. So I'm going to want negative 1 and positive 1 here, because I know positive 1 times negative 1 would give me negative 1. 2c times c would give me 2c squared, and 2c times negative 1 plus 1 times c would give me that negative 1c in the middle. Now, with this, sorry for that technical difficulty. With this, we're really going to be solving for c in this case. Now, c would be equal to negative 1/2, and c is also going to be equal to 1. And remember, c is just the cosine of x. So we're asking, when does the cosine of x equal negative 1/2? And when does the cosine of x equal 1? Now, remember that all students take calculus. We have the cosine of x equal to negative 1/2. We know that's going to happen in quadrant 2 and quadrant 3. The reference angle in quadrant 1 would be equal to pi over 3. We know that pi over 3 is not one of the answers, but that's going to be the reference angle for the problem. So the angle in quadrant 2 with the reference angle of pi over 3 would be 2 pi over 3. And the angle in quadrant 3 with the reference angle of pi over 3 would be 4 pi over 3. Both of those will make the cosine of x equal to negative 1/2, which makes the answer equal to 0. Now, the cosine of x being equal to 1 actually only happens one time, and that's when x is 0. Okay? So in this case, we only end up with 3 separate answers. Okay, so that's basically it for the second video. I just wanted to give you guys a couple of examples without making the first video super duper long. But this is really just solving equations with the double angle formulas. So check out part 3. We're going to talk about the half angle formulas and doing some more application problems with those.